Hello friends, in this video I am going to show you how to receive an SMS from SIM900 or SIM800 modules and how you can process it to perform different actions. For this demonstration I am using a SIM900 GSM module which I got from radolabs.com and a CP210 to USB to UART converter and an Arduino Uno board. First I will show you some of the basic commands you need to understand how the SMS reception works on SIM900. And this tutorial applies to SIM800 as well because the commands and everything remain the same. For this demonstration I am using a SIM900 TTL GSM module from radolabs.com and this board runs at 5 volt input and it has a voltage level translator inbuilt into it so that you can directly connect the 5 volt UART lines of the Arduino directly to the GSM module. Because SIM900 can only take in I/O voltages of around 2.8 volts. Since our Arduino Uno is now running at 5 volts, we can connect 5 volts to the V interface pin and it will convert the voltage levels coming from SIM900 to 5 volts and voltage lines coming from the Arduino Uno to the GSM module to 2.8 volts. I am also using this CP210 to USB to UART converter which is having a RS232 interface and a TTL interface. So I am directly using the TTL interface of this converter to connect to the Arduino Uno or the GSM module. This is the Arduino Uno board I am using and I am only connecting the TX and RX lines of the Arduino to the GSM module. When you are making the connections, make sure that you are connecting the TX line of Arduino to the RX of GSM module and TX line of GSM module to the RX of Arduino. Before we begin, we need to understand some of the commands used to set up the SMS reception on SIM900 module. Open any of the terminal softwares. Since I am using CP210 to USB to UART converter, it is detected as COM8. I will leave the baud rate settings to default and open the terminal. Now let's test basic AT commands. Everything seems to be working okay. Now before we do anything, the GSM module should be set into text mode using the command AT plus CMGF is equal to 1. Now for our application wherein we need to receive an incoming SMS and take action based on it, what we need to do is we need to read the messages which are present on the SIM card memory. What happens is whenever a SMS is received, the GSM module reports it on the UART using the plus CMTI URC, and after that it saves the message contents into the internal memory of the SIM card. So to take any action based on reading the SMS, we need to first read the message from the SIM card memory and then process it and take action based on it. So to read the SIM card memory, we use the command AT plus CMGR is equal to 1, which will read the first message in the SIM card memory, and then AT plus CMGR is equal to 2 will read the second message. And now suppose if you want to read all the messages present on the SIM card memory, you need to use the command AT plus CMGL is equal to all. And this will show us all the SMS present on the SIM card memory and it will put it on to the UART port. Now imagine you are a microcontroller instead of the terminal software. You need to keep all this SMS into your buffer and then process it one by one. Now let us see how an incoming SMS is reported. I just sent an SMS to the module. As you can see, the incoming SMS is reported using the URCs plus CMTI SM,6, means an SMS has arrived and it is placed in location number 6. Now if I read it, AT plus CMGR is equal to 6, it will show it. Now suppose if I want to delete this message, AT plus CMGD is equal to 6. Similarly, like we have AT plus CMGL is equal to all, we don't have a AT plus CMGD is equal to all, so that we can delete all the SMS. So we need to delete the SMSs one by one. Now for our application, what we need to do is we need to look at this URC which is plus CMTI followed by the SMS number, and once we get the SMS number, we need to use the command AT plus CMGR is equal to SMS number, which will give the contents of this message, that message, including the sender's number. Now this is a two-step process wherein we need to wait for the incoming message and then issue another command to read the contents of the message. I will show you one more way wherein using the command AT plus CNMI is equal to 2, 2, 0, 0. What this command does is, I will show you. I will send a message. I will send SMS hello. Now what this does is, instead of only reporting the URC plus CMTI followed by the SMS number, it will directly give the plus CMT URC instead of the plus CMTI, and it will give the sender's number, the date and time, and the SMS contents also. So using this command, you can directly process the incoming text messages instead of issuing double commands and finding out in which SMS location the command has arrived. So once you enable this command, so whichever SMS follow, will be directly reported. So if once we do this, you can use the command AT and W. What this does is, even if I restart the module now, I will reboot the power. Now I have rebooted the module, and AT plus CNMI. As you can see, the module has saved the configuration settings whatever we had done so far. T plus CMGF. Even the module is set to text mode by default. Once you do this configuration, you need not do it repeatedly because the module has saved it in its internal flash or EEPROM memory, and you can directly go to your main function, main loop function, and wait for the incoming message or the text command. Now since you have known this, now let's go to Arduino and try to read all these incoming messages and process them based on the commands we want. Brownies TX. TX to RX and RX to TX. This is a simple code which I have written, which declares a buffer of 250 bytes, and it will have a buffer index, and it will set the border to 9600 bits per second, and it will print a welcome message, waits for some time, and it will set the GSM module into text mode, and it will use the CNMI command to indicate to the GSM module to put out whatever the incoming message is onto the UART port. We will clear the buffer using the memset command, and we will initialize the buffer index to 5. In the loop function, we enter an infinite loop wherein we check whether there is any serial port data available, and if there is any data available, we read it into the buffer buff. And now in this statement, what we are trying to do is we are trying to find out if the command at C1 is appearing consecutively. Means the current character is received in buff of buff index, and the buff of buff index -1 will have the previous character received, and buff of buff index -2 will have the previous character which is received. Now we will compare whether the current received character is 1 and earlier received was C and the previous one was at. If it matches, then it prints the string command 1. And similarly, we are trying to detect one more command which is at C2. We can add any command we want here. We will add CMD. And we will print So we'll print CMD if the CMD characters were received. Now let's try to compile and program this one. Before you program, you need to remove the serial port connections of Arduino which are connected to the GSM module. Okay, the upload is complete, and we'll connect the UART lines back. Now we'll open the serial port terminal or the serial port monitor. It will run and initialize the GSM module to text mode and to the set CNMA command. Now the Arduino has initialized the GSM module to text mode, and it has also initialized it to send any incoming messages onto the serial port. Now let's try to send an command. I'll send command 2, which is @C2. So command 2 has been received. Now I'll send command 1. Okay, command 1 is also received successfully. Now I will send command cmd. Okay, command cmd is also received. Now I will put back command 2 again. Okay, so this is how we receive an SMS, we process it, and we can take action based on it. And instead of printing command 1, command 2 and command cmd, you can put your own code which will perform a specific action based on the command received. Maybe you can put a code to turn on or off an LED or an IO port which might be connected to a controlling device like a relay or a MOSFET. This is the very important part of the code wherein we are continuously reading the incoming data and continuously trying to match it to the predefined commands. So this method can be used to either detect a command in an incoming SMS, or if your Arduino is connected to a Bluetooth device or a serial port Bluetooth device, then you can use the same command to detect an incoming command from an Android app or something. So that's all, I guess. Thank you for watching.